Do you want to run Klipper firmware, but you can't find a Raspberry Pi? Well, you do have a couple of options to get around that, and we're going to take a look at one today. This is the Fly Gemini version 2 from Mellow 3D. Hello everyone, Chris here, and yes, Raspberry Pis are still really hard to get. And depending on your install of Klipper, you're probably going to need one to get up and running. Now, there are several ways around that right now, but one of the more common things we're starting to see on main boards are chips that can run Linux alongside your MCU for your 3D printer. So all of that is contained on one board. And we're going to take a look at one of those today. This is the Fly Gemini version 2. Now, this board has a lot going on. There's all kinds of features integrated. It's going to take a lot to get through all of it, as well as installing that Linux distribution that runs on the board to be able to get you up and running Klipper. So we're not even going to get it installed on a 3D printer today. This should be more than enough for one video. But let's not waste any time. Let's see what you're going to get in the box when you purchase a Gemini version 2. So here we go. We have our board, and we've got a bag with some pigtails and some connectors in it. We'll go over that. Also, you get all of the pins so you can make up your JST connectors. I'll show you the other side when we open the board up. So here's our main board. You can see there's all kinds of different things going on here. Let's just kind of get a lay of the land first. One of the first things that I started to look at were the pigtails that this board came with. You can see these connections right here. They're very small types of connectors. They would be really hard to make if you had to make one on your own. Again, they do come with the board, but them being that size might not make it so convenient for everyone else. We'll go over what those actually are here in a moment. But you can see we have the Raspberry Pi-like section. We have a network adapter that is 100 meg. We've got 4 USB adapters, the SD card holder that would support Linux, and then we have our processing chip that would process Linux. This chip is an all-winner H5 chip. It's 4-core, 1.5 gigahertz, 64-bit. Corex A53. So something comparable to what you would see on a Raspberry Pi. And then you have memory down here. 2 chips of 512 each. And something unique to this board, you can see this connector right here. That's an eMMC SDIO. You could plug in a drive there if you'd like. They even make a 1 gig extension for your Linux file system if that's the way you want to go. But you don't see that on boards very often. Next up to note, depending on the mode you'd like to run this board in, you have these different sets of dip switches over here and over here. Some of those will be required to be set depending on what firmware you'd like to use. So note that that's how you configure these. So let's just move around the board from there. We'll just kind of go counterclockwise. We have an HDMI connection for the Pi. We have our core UART for communications. And then we have the board USB. So this side Pi, this side MCU. And then the SD card holder for the MCU side for the 3D printer. And you'll notice all of the plugs have a JST connector in them. It comes with the pins where you can make the connector up, but this is the plastic shroud you would use. You just pull it out. Down here we do have our CAN bus connection. We've talked about CAN before. It's just a communication device you can use rather than using serial. You see a lot of jump out boards now where you can use CAN. And then some connections down here where you can use one of their color screens. Down here we have the thermistor for the bed. And then we have lugs for all the power. This one is for the heated bed. The one in the center is the mainboard power supply. And then you have driver power here. So these two are 12 to 24 volt. With the drivers you can go from 12 to 48 volt. So you can power them separately if needed. And note, these connectors here, these are for the blade fuses. The fuses don't come installed. And they're side by side accordingly, which one you'd like to use. Moving on up here, this is the thermistor for your hot end. And then we get into some interesting features. These jumpers right here, that will allow you to select the voltage for your fan. You can run it 5 volt, 12 volt, or 24. So you just use your jumper there. These are your controllable fans. Those can be controlled in G-code. Then you have an always on fan up here. And then right down here, that's the MOSFET for your fans. It's replaceable. So there's a board that slides in. You get one with this board. You just mount it here. If you happen to blow one up, you can always pull it out and put in another. You have the plug for your hot end heater. And then down here, that's for something like BL Touch. So servo pins with some in-stop pins. And you'll notice this board only has 4 drivers. So you're going to have to be kind of choosy which board you'd like to use. Now, they do make breakout boards. Like I said before, you can put them on the can and get more drivers. But just be aware of that. They do make a bigger version of a board like this we'll look at in the future. But only 4 stepper motors and 4 connections for this one. And just to note, this is E, Z, Y, and X. And then you have your XYZ limit switches for your end stops if you still have them. And then a port that you can use for a cooling fan for the board. You have standard ports for LCD, EXP1 and 2. You can use something like 128, 64. And then we get down to these small pins right in here. Now, this bank right here, they're just normal pins. That is ST-Link, which is pretty unusual, but could be really handy when running an STM32 processor. This is where you could do some debugging or directly talk to that processor if needed. So handy to have, maybe not usable for most users, but they are there. And then down below that, we actually have a UART1 and UART2. So separate serial interfaces. So let's say you could put a TFT screen on one and then have another one open to communicate with another device. If you've ever run into collision on your serial, having 2 could be really handy. But again, you do have these JST connectors. They're much smaller. They'd be really hard to make yourself. You do get these pigtails. They're open on the other side. But if you want to use that, just be aware this is how they're configured with the smaller type of connector. Also with the 2 down below. Those are SPI dev pins. Again, you could use one for something like a TFT. It just depends how you want to configure it. Or the other one for your accelerometer. That would be for something like input shaper. So you can treat them kind of as GPIO pins into the section where it's Raspberry Pi-like. You can talk to Linux. All that will have to be configured. But again, they're these pigtails with the smaller pins on them. Just be aware. And then last but not least, here in the center, you have a USB to CAN module insertion port. There's a board that goes in here. So if you want to do CAN with that module, it will accept it. Again, another add-on that you can get for these boards. And if I didn't mention it already, the MCU on this is the ARM's STM32, but it is an F405. Just in case you need to know that. And as always with most boards we see now, they have really good badging, what the pin numbers are, so you can use them in your config. But it's also good to see the Mellow 3D logo alongside the Team Gloomy logo. They're the ones that do a lot of the development on the firmwares to make this all happen on these boards. So thank you to them. And here's all the rest of the connectors I didn't show. There's your MOSFET for your fans. You have your blade fuses. You do get some blade connectors to hook up your power, miscellaneous jumpers, and a small USB-C. So we're just getting started here, and as you can see, there's a whole lot going on this board. Probably way more than most users would need. But if you were to need it, it is there. And these boards are only around $50. You would have to add some drivers, and it does only have 4. But given that limited capacity, and you could add some via CAN bus, it still could be a really valuable main board. Now, nothing is free, of course. You do have to get Linux installed on it, and it's not all that straightforward. Right now, you have to use one of their distributions to either run Klipper or RepRap. Remember, Duet 3 boards, you would need something like a Raspberry Pi to put on top to enable wireless connectivity and some other things. So keep that in mind if you're making a selection for one of these boards, even if you do want to run RepRap. You could also run Marlin. I'm not sure that Marlin supports this processor as of yet, but it could be doable. You just wouldn't have the Raspberry Pi. It's not going to be that useful for a Marlin user. So let's continue on with our Klipper install. We'll see what we can do. We do have just a little bit more hardware set up to go. So the first thing you're going to want to look at when you get a board like this is what drivers you need to install, because you do need to purchase one. Mellow 3D was nice enough to send over some 2209s that we can use, but this board will pretty much support any driver that you have. You have all of these jumpers down in here where you can set the type that you use. If you fully populate them, you're able to use the same old stepper mode that we would use back in the day. A4988s, 16 times microstepping, all that good stuff. And then if you want to use UART mode, like for a 2209, you just put the jumper on. And then SPI, again, you can use all the lower ones down here to select the mode that you want to use. That'd be something for like a 2130. Most common nowadays, we just run UART on all of these. These boards are smart boards, so you can use all the features of the driver. So for UART mode, we would just use these two pins right there, and we'll just do that for all four of the drivers. Now, one thing I'll mention when you're installing your drivers on this board, this is still kind of the old school mode here. If you don't want to use centerless homing on these boards, you would have to cut your diag pin, because it's going to conflict with that end stop pin if you'd like to use a switch. So be aware of that. These boards don't have the jumpers like a lot of boards do to configure that. So make that choice before you install your drivers. That's mostly just a rule for X and Y on a lot of boards, but consult the documentation. But your driver will just go on just like that. Then you can install your fan MOSFET. We have the chip right here. It goes towards the drivers. It goes in these three pins right here. And then as far as hardware in the box, all you have left to do then is install your blade fuses. Depending on the ones you need to use, that's the one for the bed. This is the one for the board. And if you run a separate power supply for your drivers, that fuse would go right here. So as far as things that come in the box, this is all the install we need to do. Now, you might have to make adjustments again on these dip switches, depending on the firmware you use, but we'll take a look at that. So some things you might want to consider when you're doing this install: you will need at least one SD card. I went with a 32 gig for the Linux side of things. The MCU side for the 3D printer, it also has a slot. If you'd like to use that with your configuration, it would work just like any other 3D printer. And then the wireless dongle. Mellow does recommend you use this one. There's usually a link provided for these, but this board does not have integrated wireless. You could use the Ethernet port if you wanted to, but the dongle is going to make it a lot handier. So we're going to use that today. Okay, so we've already said a lot, and we just went over the hardware pretty much that was in the box and what you would need to get this up and running. Now we're going to move to the Linux install of the distribution they recommend. Again, I'm not going to put it on the printer today, but it's going to be enough just to get this thing up and running. There's quite a few steps here. So let's jump to the computer. So as I see it, one of the downsides to this configuration is you do have to use the distributions from Mellow 3D to make these work at this time. I'm sure that will change, but right now it's just a little bit convoluted and you're dependent on their software versions. But for now, you're going to want to head to mellow.klipper.cn. And here's the start page. We'll just go down to start. And then over here is where all your information is going to be. They do have a somewhat comprehensive walkthrough here in text that you can use. I would just start in System Image and go through Prepare. It'll show you how to burn the card, but we're going to walk through all of that so I can show you how it's done. But to get us started, again, we're doing Klipper. Let's just go ahead and go to System Image. And here's the one for Fly Gemini and Fly Pi. But this is the latest version. It has Klipper already installed. So we'll just grab it. When the download's complete, I just use the Raspberry Pi tool to write that image onto the SD card. We've been doing that for a while now. But you can just choose your operating system, use Custom, and then find that downloaded image. Hit Open, choose your SD card, and then we can write. Now the Raspberry Pi tool, if you remember, we have settings down here. You can write specific things to your image. We can't do that with this distribution. It doesn't have a config file, so we're just going to write. We'll have to configure it after the fact. And we want to continue. You can see our custom configuration options errored out because there's no file. Just hit continue, no big deal. But then now we can take out the SD card and mount it on our board. So the SD card for your Linux, again, it's going to go down here in this port. Now, you will have to have a bin file to install Klipper on the MCU. So you're going to need an alternate card. I know I only mentioned using one, but with Klipper installs, you're almost always going to need two. You could use this other one, but it's going to be a mess. You don't want to do that on one of these combined boards. Just grab a smaller card that you have laying around. Also, again with these dip switches, to run Klipper, we need to change a couple of these down here. We'll have to remove our plastic here, and then to run Klipper 3, and 4 will need to be moved up to the on position. And if you're really good, you can put that plastic back on. And if you're using your Wi-Fi dongle, you can go ahead and install that now as well. Now for our initial testing here, to get Linux to boot up, we're just going to power it with USB. So we can do our initial configuration. So we're just going to cable up to the computer, USB-C, to this port right here, and you're going to see some lights start to turn on. This should start Linux booting. When Linux starts to boot, you'll see some more lights. It's going to try to engage the wireless. This is a good sign, you know it's processing something. If you're a Windows user, the next thing I would do is go to Device Manager, just to make sure that the board can communicate successfully with your computer. Just pop open COM ports, and you can see COM4 CH340 device. If you don't see that, you usually need a CH340 driver. If you just search Windows CH340, you'll find the file, download it. That should get you communicating with the board. But we're up and running, so we should be good. Now we need to talk to this board with some sort of terminal to complete the install. I usually just go with the Putty tool, but we're doing this over serial, remember, and we see that we have COM4, so we're going to have to do it just a little bit different this time. So I'm just going to open up Putty. We're going to tick the serial radio button. We'll update that to COM4, and your speed is 11.5200. And then we can hit open. Now it might be blank at first, but just go ahead and hit enter. And you can see we're at root, the user, fly Gemini. So we're communicating over serial with the board. So far, so good. Next up, we need to set up that wireless adapter so that we can communicate over IP rather than serial. So we're going to enter NMTUI. This is going to take you to some menus so that we can set up that connection. We're going to activate a connection. Down here we've got Wi-Fi. This is my Wi-Fi network. And then just enter the password for your Wi-Fi. It is case sensitive. Then you can hit OK, and it's going to connect up. If the light on that Wi-Fi dongle is now blinking, then you should be good to go. We have connected to the network. And then we can just get out of this menu by hitting escape and quit. Now we just need to know what IP it grabbed when it connected to the wireless. You can just do an IP space A. Here's your Wi-Fi adapter right here. And here's our IP address. So from here we can use that to access Klipper. So we'll pop open a browser, and we'll go to 192.168.1.70. And here's Fluid. Now you can choose either Fluid or Mainsail. From here you could uninstall Fluid and put Mainsail on if you wanted to. That's another set of steps, but I think both of them are pretty handy myself, but it just depends on what you like. Now we need to jump back to the terminal. I know there's a lot of steps here, but we need to get out of root and go into the fly user. Now that the Pi is actually on our network, we don't have to use serial any longer. So we'll just exit. Back to the Putty tool. We're going to SSH this time to that IP, 192.168.1.70. And we'll accept the key. And then you want to use username fly, password Mellow. And here we are into their operating system on the board via TCP/IP basically. This is a more acceptable place to do our configuration rather than through a serial console. Now that we've got Linux up and running, the Klipper install is pretty much just a straightforward Klipper install. You would do it just like if you had a regular Raspberry Pi and a 3D printer mainboard. There are a few little differences that I will show you. We're going to go ahead and complete it, but you can see what it takes to get up and running. It's just a little bit different from the regular Raspberry Pi install. So just be aware of that when you're going to one of these boards. I do hope soon we'll be able to use pretty much any distribution on this board, but time will tell. So back to it. So from here, let's just do an ls. You can see we do have a Klipper directory. This has Klipper already installed. We can just cd into Klipper. Take a look in there. All our usual files. Now we just have to do our make commands so that we can get a firmware file to load onto the MCU. And if you're doing make, first thing I would do is do a make clean, just in case you want to clear out anything that might be in there. And then we'll do our make space menu config. And here's our option menu to set up Klipper. Now from here, compared to a lot of other boards, there's not a lot we have to set up because it is integrated. We do need to set the processor like every other board, so we'll hit enter on that. And we do have an STM32. And then the processor model for one of these, that is an F405. So we'll enter that. Bootloader offset should update to 32K, and you can leave communication interface PA11, PA12. So we're good there. Hit Q, hit Y to save it, and there's the config. Now we need to make that config, do the compile. Now usually you would just run a make. Mellow does recommend you add a -J option for number of jobs, and they set theirs to 4. Now I don't know if that's a limitation of the processor on the board, but this is what they recommend, so that's what I'm going to have you do as well. So make J4, and it's going to run a while. Now our compile is complete. We have our clipper.bin file, but you still need to transfer that over to an SD card so we can use it on the other side of the board. There's no communication in between those two to get that done. So we have to use WinSCP just like we do for any other Klipper install. So we'll open up WinSCP, and we'll just go to New Site. SCP is what we need, and we'll use that same IP, 192.168.1.70. Port 22, again, Fly is the username, Mellow is the password. We'll log in, and just like any other Klipper install, we'll go into Klipper, into Out, and here's our clipper.bin. I'll just right-click, download that, and save it to my desktop. Now here's where that other SD card comes in. I did mount one on this PC. Make sure it is formatted FAT32. This is just a 16 gig card. Use something smaller than a 32. When the format's complete, we'll just grab our clipper.bin. We have to rename it to firmware.bin. And we'll copy it, paste it on our SD card, and then we can take that card out and load it on our main board. So back to the main board, I have plugged in a couple of thermistors, one for the bed and the hot end, because it does throw a lot of ugly errors if it can't read the thermistor. We want to be able to get just a little bit further, so I can show you a few things. But here's our SD card with our clipper.bin. It goes in this slot right over here. And then you can just hit the reset button right there. And that's going to flash the MCU with Klipper. After we hit reset, we jump back to fluid here. You can see our temperatures have smoothed out because we added those thermistors, and Klipper did start. You can see down here Klipper is ready. We should be in good shape. Now with this board, if you go this route, installing their software like we just did, if you go over to configuration, you're going to have a printer.cfg. They've already made one for you. Head in there. This is for this board. Now, of course, you're going to have to add all of the other items. However your printer is set up, you will have to reconfigure in here. But again, these printers.cfg files, that's a lot of work. You can see even here they're set for 2208s, we have 2209s. All of this is going to have to be updated, custom to whatever configuration you want to do. But we are up and running Klipper, and Klipper is running, Linux is installed, without the use of a Raspberry Pi, and that was our main goal for today. But one thing I did want to mention is the MCU for this type of install. You can see we have this temp Klipper host MCU down here for the serial. That is all intact. Our MCU up here, we have this TTY ACM0. You don't have to go get that device name. But to verify that Klipper has been compiled and it's been flashed to the board successfully, there's kind of a cool interface. You don't have to just do it through the terminal. Usually we would do something like an ls/dev and take a look at serial and then by-id. There's the MCU ID the board is communicating. So we know that we flashed successfully. But what they have done is give you an interface to pull that up via the web. So if you just go to your fluid configuration, just enter the IP into a browser and then put 4 nines after it, :4 nines as the port, it will give you that device ID down here. So I thought that was kind of a nice add-on. Again, you're not going to need it for this install, but this is a verification that you're set up correctly. But now you're ready, set up on this board to do your custom configuration till your heart is content. So there it is, the Mellow Fly Gemini version 2. We got Klipper up and running without the use of a Raspberry Pi. Given this board is around $50, you add some drivers, this is a very affordable solution for running Klipper. Now, we just scratched the surface on this one. There's a lot more you can do with this board. Again, we didn't even get it installed on a printer. But this should be more than enough to get you up and running with the software, and you can just move straight on to the hardware. I find a lot more folks are a lot more comfortable with the hardware side than they are the firmware install. So hopefully you found this helpful. More boards like this to come. That will be it for today, but I'll see you really soon on the next one.